Hey guys and girls, welcome back to another lesson. In this lesson, we are going to be exploring the world of custom functions. So what is a function, first of all? Well, this is a function. We are using the plot function to plot nothing onto the chart. If I change this to close, now we're plotting the closing price directly onto my chart using the plot function. And this plot function takes several input arguments or parameters, which we've already covered in the basic section of the course. We can also create our own custom functions that behave the same way as the inbuilt functions, meaning we can create reusable functions that contain arguments and parameters that we can specify in our script dynamically. So in this lesson, I'll show you a couple of different examples of custom functions and the syntax behind creating them. So let's start with a simple one-line custom function. I'll get rid of this plot for now. So I'll define a one-line custom function. And for this function, let's just add two numbers together. So I'll call this function addition. Now the syntax for defining a custom function looks like this. We give the function a name, then we give it arguments. Arguments can also be called parameters. So we could say parameter 1, parameter 2, parameter 3, etc. And these can be any data type we want. They could be numbers, they could be strings, they could be whatever we want. And then to define what this function does, we need to use the equals right arrow, and then we create our function code. And this function code can interact with these parameters. So these parameters can influence what the function does. So let's add two parameters together. Let's create two parameters called x and y. And then we'll define our custom function with the equals right arrow operator. And now any code that follows this operator will inform PineScript what this function is supposed to do. So to keep it simple, let's just add x and y. Now this function will return x plus y when we use it in our script. So for example, let's plot this value onto our chart. Let's plot 1 plus 1. I'll close off those parentheses, save the script. Now instead of plotting the closing price, we are plotting 1 plus 1. And obviously we could change this to any number we want. For example, 23 and 33. Save the script. And now our custom function is doing this math for us, and we can call this function as many times as we want in our script with as many different variations of the input parameters that we want. So that's an example of a one-line custom function. And this code could do anything. It could detect a candlestick pattern. It could check market conditions. It doesn't need to be simple math like this. It could be anything. So the purpose of custom functions is that if you're doing something in your script repeatedly and you want to reuse that code, instead of copy and pasting that code throughout your script, you can just create a single custom function that does whatever you need it to do. And then you can call that function to save yourself time and make your script a little bit more efficient. So that's a one-line custom function. Let's have a look at how you create a multiple line custom function. So we'll call this multi-line function. And let's call the function multi. And we'll give it two parameters again. Let's just stick with x and y, keep it simple. And then the way we define this custom functions code across multiple lines is we still use the equals and then right arrow operator, but now we need to press enter and then tab or hit space 4 times. And now we can do whatever we need to do on these multiple lines. Anything that occurs after this function operator and has an indentation of 1 tab belongs to this function. All of this code belongs to this custom function, and we can do whatever we want across multiple lines. So let's keep this simple. Let's try declaring a value. Let's create a new variable called value, and we'll give it a value of x multiplied by y. And then let's also plot this onto our chart, and let's keep it simple. Let's try 2 times 6. Now when I save this script, we'll be getting 2 lines drawing onto our chart. Let's change the color of this to color.red, and we have 12 and our addition plotting as well. Now, one thing that is important to mention here is that we just created a variable within the scope of this multi function. Now, what does that mean, that this exists within the scope of this function? It means that this variable belongs to this function, and no other function, no other part of our script can reference this variable. It's a secret variable, if you will. and only the multifunction knows about it. And so what that means is if we try to plot this value onto our chart, if I save the script, we're going to get an error because this plot function is inside the scope of our total script, while the value variable only exists within this little box, this multifunction. And so the multifunction knows what value is. We can reference this variable within the function. So for example, we could say value times 2. And if I comment out this line and save the script, we will be getting 24 drawing onto our chart because we are multiplying 2 by 6 and then multiplying that value by 2. And we're doing that by referencing this value variable within the scope of this multi-line function, but this variable doesn't exist outside of that function. So that's important to mention when dealing with functions. However, you can reference variables that are in the script scope. So a variable that exists within our entire script can be used within a function. So for example, let's set our multiplier variable to 2. And if I copy that and paste it over our 2 down here, if I get rid of this plot value function call and save this code, this will work even though we are referencing a variable that wasn't created within the scope of this multifunction. Because multiplier belongs to the entire script and the whole script can reference it, so can our multifunction. So scope only works in one direction. We have our overall script scope. And let's say we create a variable called x, and then we create a custom function with a variable called y within that function. Y can only be referenced by that function, but x can be referenced because it exists in the parent scope. That's called a parent scope when you have a scope within a scope. This multifunction is a child scope, I guess. I don't think that's the official term, but if we're going with the parent-child analogy, that's what this is. It's a child of our script scope, our total script code. And then you can have scopes within scopes. So essentially we can have scopeception occurring in our script. So for example, we could say if x equals 2, then multiply this value by our multiplier. And now this code exists within the scope of this if statement, and this if statement exists within the scope of our multi-line function, and our multi-line function exists in the scope of our entire script. And now if I save the script, we'll still be getting 24 plotting up here. But if we change x to, let's try 3 and save the script, now our function is plotting NA because this if statement is not returning anything if x doesn't equal 2. So what we need to say here is else value. And now this is saying if x is equal to 2, multiply our value by our multiplier. Otherwise, if x is not equal to 2, just return this value, x times y. So now if I save the script, we're getting 3 times 6 plotting onto the chart. So that's how multi-line functions work and how scopes work. A quick crash course into scopes. We'll cover scopes in more detail in its own lesson and how indentation works in Python scripts. But let's move on to creating a multi-result function. So this is a function that can return multiple results. So here I'm going to comment and say multi-result function, and we'll call this function multi-result x and y. So it has 2 input parameters, x and y. We need to define our function with the function operator. Let me move this plot back up here. And now let's start a tabbed line, and we can start writing code for this multi-result function. So for this, let's create 2 variables called a and b. And a is going to be set to x plus y, and b is going to be set to x minus y. So we have addition happening and subtraction happening in the same function, same custom function. And now if we want to return both a and b, we can simply use the square brackets and just include the list of variables we want to return as a collection of results. So if I do a, comma, b, this function will now return both a and b values when we use it in our script. Now the way we access these 2 values, these 2 variables, is we need to use these square brackets here. And I can say R1, short for result 1, and R2 for result 2. equals our multi-result function, and then we need to give it an x and y parameter. So let's just do 1 and 1. So 1 plus 1 and 1 minus 1 is what this function will do when we call this line of code. So now let's plot R1 with a color of color.blue. And let's comment out these other plots so we don't get confused. And let's plot R2 with a color of color.red. So our addition result will be in blue, our subtraction result will be in red. Let's save the code. And there we have it. 1 plus 1 is 2, 1 minus 1 is 0. And we're getting our multi-result using this square bracket operator here. So that's it for our custom functions. That's the various ways we can use them. We can create a single line function that does something very simple. We can create a multi-line function that does something a little bit more complex with multiple scopes. And then we can create a multi-line function that returns multiple values. One other thing we can do with custom functions is create them in a library so that we can export those functions to multiple scripts. Meaning we write this function once, we save it in a library, publish that library, and then when we create our other scripts, we can reference this function without needing to write the code out. We can just import the function, or borrow this code from that library, and reuse it as many times as we want in as many scripts as we want. But we'll cover libraries in a different lesson because they are quite a bit different to indicator functions. They behave differently to how this works. They're a bit more complicated. There's a few more steps involved in creating a library function compared to a custom function within a script. So we'll cover that when we get to the library section of the course. For now, we'll leave this lesson here. I hope you found this interesting and helpful, and I'll speak with you in the next lesson.